Hello everyone, hope things are going well. Again, this is Mr. Mueller. What we're going to do this week is we're going to look at learning target 10.2, which is basically similar to what you did last week. Last week we started discussing how to estimate a population parameter, meaning the population mean in that case, and we did that by setting up confidence intervals. This target 10.2 is going to be very similar. In other words, we're still going to set up confidence intervals to estimate a population parameter, but instead of estimating the population mean, we're going to estimate a population proportion. So target 10.2 says I can construct, interpret, and analyze a confidence interval as an estimate of a population proportion. That Greek letter looks like a P is actually, again, called rho. Now, normally what I would have had you do if we were in class, we'd do an activity with M&Ms, and you would have gotten to eat the M&Ms afterwards, but obviously we can't do that. So I'm going to go ahead and skip ahead of this. And again, I'm going to stress this. A lot of what we're doing in this target is very similar to what you did last target. Margin of error, a point estimate, the standard error, so it's just going to use different formulas and a few different concepts. So in 10.1, we use sample data to estimate the population mean, which requires quantitative data. Your data was numerical in nature, like a sample of female heights, a sample of male shoe sizes, ACT scores, or so forth, the amount of money someone makes. Well, for target 10.2, we're going to use sample data to estimate the value of a population proportion rho. This requires categorical data. In other words, if you flip a coin, what proportion of times did you get tails? What proportion of times did you get heads, and so forth. So your data here is going to be more, it's going to be more categorical and not quantitative. So just to reiterate, we've talked about this first semester, but when we talked about categorical data, but what is a proportion? You can stop this, again, as you've always been able to. You can stop these videos at any time, pause and read through this, take notes, or skip over, so forth, if you already understand this. But a proportion just refers to the fraction of the total that possesses a certain attribute. In other words, this example where you have 4 pets, bird, fish, dog, and cat, what proportion of those pets have 4 legs? Well, the dog and cat do. So the proportion of pets that have 4 legs would be 1/2, 2/4, or 0.5. Now, again, a proportion is not a percentage. If I would ask you the percentage of pets that had 2 legs, you'd say 50%. In this case, we're looking at a proportion, which is a number between 0 and 1 inclusive. Okay? Now, just as before, as for last target, a point estimate is a single value that we get from sample data to estimate a population parameter. The only bad thing about using a point estimate or single value is we don't know how good it is. All right, and that's why we create these intervals. Now, for a proportion, to estimate the population proportion of something, the best, most unbiased estimator is the sample proportion. Now remember that sample proportion, I'm going to show you again, we call it p hat. Okay, that is the sample proportion. I know it sounds awkward or so forth, but if we, for instance, take a sample of, if we want to, let's say, for instance, take a sample of 100 people and figure out the proportion of them that have blue eyes. So let's say out of those 100 people, 47 have blue eyes. So then the sample proportion of people with blue eyes would be 0.47. Why? Because it's 47 out of 100. So again, p hat represents sample proportion. Rho represents the population proportion. So let's take a look and on your student examples, number 1, I'm just basically going to break number 1 up into parts. So as we talk about things, we'll go back and refer to example 1 and go through each part of example 1 as we talk about it in the notes. So a Pew Research Center conducted a simple random sample of 1,007 adults and found that 85% of them know what Twitter is. Based on that result, find the best point estimate of the proportion of all adults who know what Twitter is. Now again, this is it's not a trick question, but it's easier than people think. The best point estimate for the proportion of all adults who know what Twitter is. Remember, that's what they're trying to figure out is what proportion of all adults. And I don't know if it's in a state, if it's in the U.S., if it's around the world or so forth. It really doesn't say. But we're estimating the proportion of adults in the population that have or that know what Twitter is. Well, remember, the best point estimate for a population proportion is the sample proportion. In this case, it does say right here, 85% of those 1,007 sampled adults know what Twitter is. So in this case, we're not going to write it as a percent. We're going to write it as a value between 0 and 1. So the best point estimate would be the sample proportion that we got from our simple random sample of 0.85. Not too difficult. Okay. So I'm going to stop this right here, and this will be again episode 1 of these notes, and we'll go back through and we'll look at some other information like how do we actually start constructing these confidence intervals.